Area and surface area. Students will learn strategies for finding areas of parallelograms and triangles and use regularity and repeated reasoning to develop formulas for these areas using geometric properties to justify the correctness of these formulas. Unit vocabulary. Area, base and height of a parallelogram, compose and decompose, polygon, parallelogram, polyhedron, prism, pyramid, quadrilateral, region, and surface area. Prior grade expectations. It is important for you to understand where you came from to decide where you are going. If you look at this image, you can see that in grade 1 we started with breaking up or partitioning rectangles and circles into halves and quarters, and in 5th grade moved to tiling to find the areas of rectangles with fractional side lengths, multiplying to find the areas. In 6th grade, we will move into understanding the area of a triangle is half of the product of one of its side lengths and its corresponding height. We will find the areas of polygons. In lessons 1 and 2, we will work on tiling the plane. In the image shown, you will see that all of the area is covered. There are no openings, blanks, or spaces in between the tiles. This is called tiling the plane and shows all area being covered. Here is another image that shows a square being decomposed into 2 triangles and recomposed into a larger triangle with all 4 smaller triangles. The final image is of that triangle being put back together or decomposed back into the 2 squares that it originally started as. In lessons 3 through 6, we work on decomposing shapes and moving them to create polygons that we are familiar with. For example, if we look at this Z shape, it is difficult to try and find the area until we move the far right triangle over and create a recognizable rectangle. We've taken a rhombus, added the 2 triangles of a larger rectangle, find the area of those 2 smaller triangles, and then what you have left is your area. And here is a diagram that you may see where they would look at image A, find the base by counting the bottom, then the height is how tall the polygon is, and the area is how many total squares are in the middle. In lessons 7 through 10, students work to understand how to identify the height when the base is identified. Graph paper is very useful here for students and should be used whenever possible. In lessons 11 through 15, students identify nets that correspond to polygons. The objective is that students see shapes such as triangles and rectangles that they become proficient with in lessons 1 through 10. This makes the task of identifying shapes to then calculate surface area in upcoming lessons easier for students to comprehend. Lesson 16 compares the difference between surface area and volume. Students will know how 1, 2, and 3-dimensional measurements and units are different. Students will be able to explain how it is possible for 2 polyhedra to have the same surface area but different volumes, or to have different surface areas but the same volume. Here we see a cube shape and a folded out rectangular prism on grid paper, which is called a net. These 2 lessons are focused on students understanding what it means to square a number versus cube a number. Now that they know the difference between surface area and volume, students should be able to make the connection between 2 numbers, base and height, versus 3 numbers, base, height, and length for volume. When multiplying 2 of the same numbers together, such as 5 times 5, we say we are squaring the number. When we multiply 3 of the same numbers together, such as 4 times 4 times 4, we say we are cubing the number.